In this video, we are going to talk about the introduction to algebra and the set of real numbers. So some of the things that you need to go back and think about are these three definitions: what's a variable, a constant, and an algebraic expression. So a variable, by definition, a symbol or letter such as X, Y, Z, or A that is used to represent an unknown number and is subject to change. A constant is a value that does not vary, such as -4, 2, 1/2. It's just a number, so it's just a value that does not change. And then an algebra expression is a collection of variables and constants under algebraic operations. So in example 1, our directions are to evaluate the algebraic expression for the given values. Our algebraic expression is z minus 10, and then they're telling us that the value for z is 12.2. So what we will do is we will substitute 12.2 for z. We will subtract 10 from it, and our outcome will be 2.2. That will be our answer. So we have evaluated the expression. In example 2, we have 3 times s times t. So we are going to be multiplying. So we're going to substitute 4/9n for s, multiply 1, or substitute 1/2 n for t, and then multiply out. So 3 times 4/9 times 1/2. So I substituted s with its value. I substituted t with its value. Now, when you multiply fractions, we're going to put 3/1 so that all three values are in fraction form, and I can cross cancel. 3 goes into 3 once, but it goes into 9 3 times. I can do the same thing with the 2 and the 4. 2 goes into 2 once, but it goes into 4 twice. So I go across the top and I multiply my numbers, 1, 2, and 1. That gives me a total of 2. I go across the bottom and I multiply my 1 times my 3 times my 1, which gives me 3. So my final value for that expression is 2/3. The next section talks about the set of real numbers. All the numbers that you will deal with in this class will be real. And in this section, it talks about the different subsets of real numbers. So real numbers encompass 0, all positive and all negative numbers, including those that are represented by fractions and decimals. So the real number line that you see here, you have 0 in the middle, of course. When you go to the left, when you move in this direction, the numbers get smaller, but when you move to the right of 0, the numbers get larger, okay? So we're going to take number 3 and we're going to plot these numbers in the appropriate spots just by simply drawing a dot on them on the number line provided. So 2, we'll put a dot right here on 2. -5 is to the left of 0. 1/6 falls between 0 and 1. So 1/6 is about right here. That would be 1/6. -1.8, you go over to -1, but then you have to keep going, so it's a little bit closer to -2. That is -1.8. We have -5/2. -5/2 is the same as -2.5. So we're going to go over to -2 whole and go over half. That would be -5/2. And then 3.1 is just a little bit further to the right of 3. So there would be 3.1. The subset of numbers, real numbers, which I said earlier, all the numbers that we deal with are going to be real numbers. And if you notice on our number line, we had some fractions and we had some decimals, and we had some numbers that were not necessarily written as a fraction or a decimal. So The subsets of real numbers are extremely important. So the set of natural numbers listed is 1, 2, 3, 4, 5, 6, 7, 8. It keeps going and going. There are no fractions and no decimals in this set. It's just 1, 2, 3, 4, 5, 6. It's like those counting numbers that you use to count. Now, the set of whole numbers includes 0. Still, no fractions, no decimals involved in that subset of numbers. Now, if you notice in the third set called integers, we pick up negative numbers, but there are still no fractions and no decimals in that subset. We don't get to fractions and decimals until we hit rational numbers or irrational numbers, and we'll talk about irrational numbers in just a second. But the set of rational numbers can be written in the form P over Q. Notice that is a fraction. It says where both P and Q are integers and Q does not equal to 0, which means you cannot have a number divided by 0. That is not acceptable. Okay? Now, it also says that any rational number can be represented by a terminating decimal and a repeating decimal. What a terminating decimal is if you had 1/4, that is equivalent to 0.25. That's it. It doesn't go any further whatsoever. If you have the fraction 1/3, that is the repeating decimal, 0.33333, and that decimal repeats forever. It never, ever stops. So those are the two types of decimals that represent rational numbers. So 2 or 3 things. If you can write it as a fraction, such as the number 5, 5 can be written as a fraction, 5 over 1. If it's already in fraction form, like 1/4 or 1/3, it's a rational number. Also, if it's in decimal form, it has to be either repetitive or terminating, like the examples that I've given you. Now, the irrational subset are those that cannot be written as a ratio of 2 numbers. So basically, it cannot be written as a fraction, okay? So irrational numbers cannot be written as a terminating decimal or a repeating. They cannot be written in that format. So that means that they are non-terminating and non-repeating decimals. So in the next example, 3.8, we need to describe each number as terminating, repeating, non-terminating, and non-repeating, and then classify them as rational versus irrational. So 3.8 is a terminating decimal. Okay, so it is terminating. That means it is a rational number. In B, if you remember pi, what we associate with pi is 3.14, but if you recall, pi goes on forever and ever, and it does not repeat. So 3 times pi would be a number that goes on forever, and it does not repeat. So 3 pi is considered non-terminating, non-repeating, which means it is an irrational number. Now, part C, negative 0.6 with the repetitive bar over it. So that means it's a repeating decimal, and if it repeats, it is considered a rational number. All right, so we're going to practice that a little bit more. It says in example 6, let A be the set of numbers, and you can see the set of numbers. There are 5 of them. And it wants you to list all the rational numbers. Now remember, rational numbers can be anything you can write as a fraction. It can be there are 6 numbers in that list. It can be a terminating decimal, and it can be a repeating decimal. So 1.3 is terminating decimal. The square root of 10 does not terminate. If you were to type in the square root of 10 on your calculator, it would fill up your display. It never terminates, it never repeats, so I'm going to throw it down here in the irrational list. 0 is rational because I can actually write 0 over 1 and it still represents 0. I have a repetitive decimal, negative 0.7 repeating. That falls in the rational set. Negative 10 is a rational number because I can write negative 10 over 1 and it still equals negative 10. And then 6 is also a rational number because I can put 6 over 1 and it's still 6. Now, the only other number in the list was square root of 10. I've already put that down as irrational because it is not rational. So we've got the first 2, A and B, done. Part C says list all the integers. Those are the numbers that are not decimals, and they are not, well, they're just not decimals. So that would be 0, negative 10, and 6. Those are all the numbers that we can write as fractions, but their denominators are 1. Now, moving to inequalities. The relative size of 2 numbers can be compared using the real number line. A and B represent 2 real numbers, so these numbers can be fractions, decimals, positive, negatives. They could be square roots, like the square root of 10. It can be any number. That's what a real number is. So if A is less than B, remember this is the less than side. It also corresponds to the negative infinity on your number line. A is greater than B. This symbol is the greater than side of the number line, so it represents positive infinity. Here are some mathematical expressions down here. You've got all of these that you can read, and here are some examples. 3 is less than 5, 4 is greater than 2, 2 is less than or equal to, that little line underneath, the little line underneath means it's or equal to, so on and so forth. So we're going to go on down and we are going to answer this question. So all of these symbols are called inequality symbols, even the not equals to symbol. All right. So we have a chart for the ocean tides, and you can read the rest of the sentence. I'm not going to read all of that to you, but it's asking you to decide if the ocean tide at 2:05 is greater than, less than, or greater than equal to the ocean tide at 2:24. So if I think about it on a number line with respect to 0, at 2:05, I'm on the negative side of 0, and at 2:24, I'm also on the negative side of 0. So now I have to decide which number is smaller. Okay, so the closer you get to 0, moving this way, the numbers get larger. So when we're on a number line, and I'm going to make this really big, here's 0, here is 0.04 or 0.04 negative, and 0.12 would be here, negative 0.12. So the tide at 2:04 is greater than the tide at 2:22 or 2:05. The ocean tide at 8:13 compared to the ocean tide at 8:36. My ocean tide at 8:13 is 2:13 230 or 2.37 feet, but at 236, it's more or it's less than. So the reason it is less than is because if you are here at 0, here's 1, here's 2, here's 3, you get to 2.3 before you get to 2.4. So the tide at 8:13 is less than the tide at 8:36. Now, it's wanting to know, compare the tide at 8:13 to the tide at 2:24. Well, all positive numbers are always greater than negative numbers. So the tide at 2:13, which is positive, is bigger than the tide at 2:24, which is negative. Now, the opposite of a real number means that they are the same distance from 0, but they are on opposite sides of 0, and these are called opposites. So A and negative A are opposites. So what they mean by that is if I'm 0 and I'm at positive 4 and I look at negative 4, it takes me 4 steps to get here. It also takes me 4 steps to get to negative 4. So it doesn't matter whether I'm on the positive side of 0 or the negative side of 0. Those are opposites because they are the same distance from 0. So finding the opposite of 12, that would be negative 12. And then I want the opposite of negative 18, which would be positive 18. Absolute values of real numbers. They are denoted with these vertical bars on each side of the number. And this is the distance between A and 0 on a number line. So if you notice, they give you the example that I gave you just a minute ago with 4 and negative 4. You are 4 units away. Distance is never negative. So on this number line, I am 4 units away from positive 4, and I am 4 units away from negative 4. So if you notice, the absolute value of 4 is 4, but the absolute value of negative 4 is also 4. So in number 10, the absolute value of negative 2, it takes me 2 steps to get there. If you think about it, here's 0, 1, 2, 2 steps to get to negative 2. So the absolute value, the distance is 2. 7 over 2. The absolute value of 7 over 2 is just 7 over 2. Because if you're on a number line and 0 is here, 7 over 2 is the same as 3.5. So there's 1, 2, 3, and you're at 3.5. So you had to take 3.5 steps to get there, or 7 over 2 steps. Now, number 12 is a little bit different because the absolute value has a negative in front of it. So we're going to write down the negative. It stays. It's not inside the absolute value. And then I want to know how many steps it takes me to get from 0 to 5. Well, it takes me 5 steps. But the reason my answer is negative is because there was a negative in front of the absolute value. Now, if that had been the absolute value of negative 5, notice the negative sign is inside, it would have been positive 5. So there's a big difference between having a negative on the inside of your absolute value versus having one on the outside. So pay attention to those. Number 13. Write true or false, and if you do write false, explain why. If n is negative, then the absolute value of n is positive. That is true. Because I didn't ask you to explain, but if you have negative n, it takes you n steps to get from 0 to that point. So, some definitions of absolute values that you can read. Now, we're going to go through the last few examples, and then we're almost done with this lesson. Determine if the statements are true or false. This says 7 is greater than 1. This is true. Now, if you think about a number line, that symbol is here. When you compare 1 to the location of 7, as you move this way, the numbers get bigger. When you move to the right on a number line, the numbers get larger. All right. Now, in part B, I have 2 negative numbers. And I am also using this symbol. So I want to know if the first number is smaller than or equal to the second number. Well, the best way to do this is to change them so that both denominators are exactly the same, and then you look at the numerators. So all I'm going to do is multiply my denominators. 3 times 7 gives me 21. So I'm going to change both of these fractions to have a denominator of 21. Now that means I will multiply the first fraction by 7 over 7. So that gives me negative 14 over 21, because 7 times 3 is 21. And then I'll multiply the second fraction by 3 over 3. That gives me negative 15 over 21. So when I look at the numbers, I will get to negative 14 first, and then I get to negative 15. So as I go this way, the numbers get smaller. So this is a false statement because negative 14 is actually greater than negative 15. So I'm only looking at the numerators this time. Numbers are letter C. Negative 5 is greater than or equal to negative 5. That is true because negative 5 is equal to negative 5. Remember, that's what that little line right there means. They can either be, one number can be bigger than the other, or the two numbers are equal. Now, we're dealing with absolute value. The absolute value of 1/3 is 1/3. The absolute value of negative 1/3 is also 1/3. That is a false statement because 1/3 actually equals to 1/3. Part E, absolute value of 7 is less than the absolute value of negative 8, which is 8. That is absolutely true. 7 is less than 8. And the last and final example, the absolute value of negative 8 is 8, and it should be greater than or equal to the absolute value of 8, which is also 8. That is true because 8 equals to 8. And remember, that's what that little bar stands for. If you need any assistance, extra assistance, please let me know during class time, and I will be more than happy to share some more examples with you.